Okay, let's continue with February, March 2023, 42. Question 6. Okay, just review it. Ask, you place a whole prop is 0, then you rotate it through new position, yeah, maximum pole voltage. Explain is parallel to the magnetic field lines is 0. It's perpendicular, the surface is perpendicular to the magnetic field lines is maximum. Then after that, it's just basic, trying to get you to memorize, trying to get you to simple thing first, before they start difficult thing. And you want to know what is N, this formula. We say it's a number density, and explain why Hall effect is made from silicon. Based on the formula, we say is a smaller value of N, so greater Hall voltage. Right? From this formula, N is small, pH is large. Large is easier to measure lah. Then we use a Hall voltage, a Hall probe. We have maximum voltage at magnetic field is 32 millitesla. Okay, calculate. So now we have a whole voltage at maximum reading 24 millivolt and placed in uniform magnetic field of 32 millitesla. The same Hall probe is then placed in a magnetic field of fixed direction. The direction is fixed now in magnetic field, but varying flux density. The Hall probe is in a fixed position so that the angle between the Hall probe and the magnetic field is the same as when the Hall voltage is 34 millivolt. The variation of Hall voltage on the probe with time t equals 0 to time t equals 8.6. That's the graph. It's in the figure shown. The coil of 780 turns and diameter of 3.6 cm is placed in a varying magnetic field. The plane of the coil is perpendicular to the magnetic field lines. Calculate the maximum electromotive force induced in the coil in the time t equals 0 to t equals 8.6 seconds. So instead of Hall probe, we change the magnetic field this time, but we replace the Hall probe with the coil. So how do I calculate the induced EMF? Can
Uh, 1.4 seconds.
basically I have to find the magnetic field first, the distance there. So we want maximum is here. Remember, magnetic field is proportional to Hall voltage. So Hall voltage is actually a measure of magnetic field. So you want to find maximum EMF. Maximum EMF is the slope, that slope. So I'm using the Hall voltage as that one, 36 millivolt. I'm using the magnetic field. Magnetic flux density is proportional to Hall voltage. And then that one is this one there. Right? So I want to determine the magnetic field, maximum or voltage. So I take this across there. So B is 32, VH is 24 from here. 24, 32, and 36. 36 is from here for voltage. Right? That one, voltage, I want to find VP. Oh, basically, this is given. This with a whole probe. Whole probe which is 2. And then this is the whole voltage for the new magnetic field. We want to find new magnetic field where the whole voltage is 36 here. 36. Copy that. That's the magnetic field used. And induced EMF is the change in flux over the change in time. Right? And then flux is BAN. A and N constant, take it out. So dB dt. So this is the slope. This is the slope. You can take any point, but I prefer to use the maximum, easier to read. Area of coil, pi r square. Okay. Diameter, change it to radius divided by 2. Then 780 turns. And it's right. That is your B maximum. And then the time is 8.6 minus 7.2. Calculate out. Can?
Okay.
These are the things that come out. At the time, you just review it. Okay. Yeah, all negative value. So yours is working this part. Remember the longer wavelength, they are far apart. Shorter wavelength, they are close together. A beam of white light passes through a cloud of cool gas. The spectrum of the transmitted light is viewed and contains a number of dark lines. Explain why these dark lines occur. Yep. Why the dark lines?
Uh, first, first the photon absorb an electron excited,
Huh? What do you think?
excited. Wait,
It's the electron that absorb the photon and move to a higher energy level. That's why the photon is missing. Okay, photon absorbed by electron, electron excited, photon energy equals to difference in energy of the two energy level. Photon relates to single wavelength or single frequency. Electron de-excites and emits photon in any direction. Okay,
mm,
some energy levels of electron in an isolated hydrogen atom are illustrated in the figure. Figure 7.1, table 7.1 shows the wavelength of photon that are emitted in a transition from N to N2 from the lower energy level as shown in figure 7.1. The associated energy level is N1 is 3.240. Calculate the energy in joule of energy level N3. You want to calculate energy level this one. They are given this one. So how do I do that? Which wavelength should I use?
uh, So I use HC over lambda because delta E.
Right? This one is the lowest one. So the lowest frequency. So highest wavelength. No? Right? Basically, we have to change the 3.4 to this is 1 electron volt is 1.6 and 10 to the power minus 19 joule. Change electron volt to joule. And use this formula. We know E2, we don't know E3. Lambda, we can find from here. This is a lambda. Okay, so E3 minus E2. Right? That's your minus E2 equals to Planck's constant and speed of light times this one. Okay, out. You get that value. Then you want to find E3. Take this over. Becomes minus. Okay, E3 must be negative anyway. Okay or not?
Okay.
Plutonium is unstable and undergoes alpha decay. Complete the equation. You should be able to write the equation. This is your AS work. And the top there must add up to give this one. The bottom there is the charge conservation of charge must add up to here. And must remember alpha for 2. Our source in space probe contains 0.874 kg of plutonium-238. Each nucleus of plutonium-238 decays and emits 5.56 mega electron volt of energy. The half-life of plutonium is 87.7 years. This reaction releases this amount of energy. And not of plutonium-238. Right? Basically, we just use this formula. This is Avogadro's number. This molecular mass or atomic mass, right? Which is get from here, 238. And then this one can either use kilogram or use gram. If you use gram for this one is in gram. And calculate the number, which is N naught. N naught is M. M is this one is in gram. Divide by 238 in gram. Then Avogadro's number, get from a data sheet. Calculate out, that's N naught. Okay, so this is given. I repeat this one. Sorry, forgotten to remove. Determine the initial activity of the source. Give unit for your answer. Right, first you find your lambda decay constant. I can use down 2 or 0.693. And this is in years. Right, change it to days. Change it to hour. Change it to hour. Then change it to second. Right, 1 hour is 3,600 seconds. And calculate out. And calculate activity equals to n lambda. Right, this is your n naught. This is your lambda. And calculate out. Becquerel or count per minute per second. Use the answer in B to estimate the initial power output from the source due to, okay, this is the activity. Right? Power is a rate of change of energy. Right? This is the energy released in one decay or one reaction. It's energy release. And the NDT is activity. So that's activity times E1. This is your E1. So E1. Right? In mega electron volt, convert it to electron volt. And then 1 electron volt is 1.6 times 10 to the power 19 joule. You calculate out. Can or not?
Okay.
The space probe will continue to function until the power output from the plutonium in the source decreases to 65.3 of the initial value. Calculate the time in years to which the space probe will function. And use the decay formula for power. This one is percent change to P or P naught, which is that one there. And lambda epsilon 2, you can use 0.693 lah. And then that is your years lah. Because you want answer in years, might as well calculate out again. No? Rather than use the lambda, the calculate is in second. And T is what we want to find. Okay, so taking the ln of this one. Okay,
Okay.
an alternative power source uses energy generated from the radioactive decay of polonium-210. We isolated the isotope has a half-life of 0.378 years. The mass of isotope needed for the same initial power output as in figure B is 3.37 gram. Suggest one advantage and one disadvantage of using polonium-210 as a source of energy. Okay, what's the advantage? Compare these two.
Set advantage, less mass, or less energy needed.
Okay. Advantage, less mass, so less energy needed to launch the probe. Disadvantage, disadvantage. Disadvantage refer to this one. This one. This one. Its half-life is very short. So it means that the number of years it can last is less than this one. So that's a disadvantage. Half-life shorter, so will not provide power for as long. Right? Why shorter time? Shorter than this one. Okay.
Okay.
Right? This is your production of ultrasound. Right? This is what came out. Okay, got time, we just review through lah. They may repeat lah. Ultrasound is used to produce diagnostic information about internal body structure. Explain how ultrasound waves are detected.
Causes shape change.
Yep. 3 mark, 3 point.
And then the shape, like the vibration, shape change of vibrations causes EMF, which is
First,
detected.
piezoelectric crystal, if a mark, we use piezoelectric crystal. Sound wave causes change in shape or vibration of the crystal. The change shape or vibration causes EMF, which is detected. Right? So it's a alternating voltage. So alternating voltage carries V varies with time t according to the equation. The voltage is applied to ultrasound probe. Mean square is given. Frequency is given. Determine the value of V naught. Okay. V naught over root 2. Right? Cross multiply to find V naught. Right? This is the root mean square value. And omega is 2 pi f. Change it there. I can expect question of AC will come out one. So you combine into two question, two topic into one question. Okay.
Okay.
Table 9.1 contains information about air and soft tissue. Determine the unit of acoustic impedance value shown in table 9.1. This AS work lah. Finding unit. So you can get from the equation. The equation there. Unit for density. Unit for speed. Okay. Simplify it. Calculate the density of the soft tissue. Like same. Playing with this formula, that's all. And put in your value for Z. Value for Z. Value for speed. Get the answer. Use your data intended to explain why ultrasound cannot be used to produce image in air-filled capacity such as lungs. Yep.
Because
To be useful,
like different intensity reflection coefficient.
it must be able to be transmitted. So if all reflected, then they cannot see anything in the lung. Okay, so that's to do with intensity reflection coefficient. Intensity reflection coefficient, you can see very large difference. So even if you subtract it, is almost the same, almost the same as this value. Same, both of them same value. This is equals to 1. So no ultrasound transmitted into air-filled cavity. A student observed different stars on the Earth. Give 2 reasons why some stars appear brighter than others. Okay?
Uh, Higher luminosity,
Say again.
higher luminosity, and
High luminosity.
closer,
Okay. The other one?
closer.
Nearer to the observer. Brighter could be closer to the Earth. Brighter could also be due to luminosity in the visible wavelength. Greater luminosity in the visible wavelength. State what is meant by standard candle. Very popular question. Memory word only.
Object with no luminosity.
That's all. Object with no luminosity. A spectrum shine from the star within the galaxy is observed to have a wavelength of that. And the same spectral line observed in laboratory, measured in laboratory is observed to have a wavelength of that. Show that the speed of the star is that one there. So you just go to your formula, you can remember good. If not, this is formula. Calculate V, take cross multiply, and put in your value, speed of light, right? That one there. As long as we use nanometer for this ratio, we are okay. Because they will cancel off nanometer. And this is a measure on Earth. Divide a measure on Earth. Calculate distance of the star. This is formula. This formula. Distance plus constant is given. Right? Put in your value. That one there. That's the speed. That's Hubble constant. Okay.
Okay.
State and explain what can be concluded about the universe based on this change in observed wavelength. Yep.
Expanding. Universe expanding.
Not sufficient. The answer is only 1 mark only. Wavelength has increased. Star has
This is
galaxy is moving away from Earth.
3
Universe
marks.
expanding, you got only 1 mark only out of 3 mark. Okay, reason is step by one. Wavelength has increased. Star is moving away. Star is within the galaxy is moving away from the Earth. Universe is expanding. Okay, let's go to the next paper. Okay, let's go to paper 4, October, November 2023,
Yeah.
41. Have you found a paper? I may have to ask you to send me the lecture note on for the PowerPoint that I send it to you after your exam Partly because I transfer it, I lost some of the info. Don't worry, I will tell you after your exam.
You mean the one you sent me in WhatsApp?
I send you your PowerPoint. Or most of it got corrupted in the transfer. So I have to ask you to send to me back.
Okay.
Cannot copy bulk Maybe have to copy
Alright.
little by little Okay found the paper Circular motion, remember all
Yeah.
terms, all the formulas, right? Condition, force is always constant in magnitude and perpendicular to velocity. State what is indicated by direction of the gravitational field line at a point in the gravitational field. Yep. We got 8 more minutes. So let me know whether you want a class next week or not. Or you want to spend your time revising.
Direction of force acting on mass placed at the point.
Direction of force acting on the test mass placed at the point. Explain with reference to gravitational field lines why the gravitational field near the surface of the Earth is approximately constant for small changes in height. Yep,
Change in height is negligible.
not sufficient answer.
Negligible compared with radius of the Earth.
It's
Or
too
s-
much.
yeah, so
That's why change in size is negligible compared with the radius of the Earth. That's one point. So field lines is effectively parallel. And
sure, can you hear me?
say again. Okay. Can hear you. Now cannot hear you anymore. A large isolated uniform sphere has a mass of m and radius r. Point P lies on the line on a straight line passing through the center of the sphere at a variable displacement x from the center as shown in figure 1.1. On figure 1.2 shows a variation with x of the gravitational field strength G at point P due to sphere for value of x for which P is inside the sphere. P is inside the sphere. The magnitude of gravitational field strength at the surface of the sphere is y. Okay, and the surface of the sphere is y. Determine the expression for y in terms of mr. Identify the symbol that is used. Right? Instead of normally we use g lah, but this one they want to use y, so we use y. G is gravitational constant. Okay,
Yeah.
explain why at the surface of the sphere G is always in opposite sign to x.
It's because gravitational force acts towards the center of the sphere. And then force is in opposite direction to displacement.
Remember your G and x are vectors. So the first point is gravitational force is always attractive. And the force is opposite in direction to displacement. Complete figure 1.2 to show the variation with G with x for value of x up to plus minus 3r, which point is outside the sphere. Okay. Right. Decrease outside the sphere. Right. Same. Remember, that's why they ask you it's a vector quantity. They are in opposite direction, so it's positive becomes negative. G is negative. When displacement is negative, right, on this side, then G is positive. Okay, so they were looking at especially this point at the surface, this point. Then this one, 2R is a quarter. Same these 2 points also. 3R is 1/9 or something like that. Okay, any comment?
Okay.
There's a marking scheme. That's how they give the 3 mark. Define specific heat capacity. Two more minutes. Define specific heat capacity.
Thermal energy per unit mass.
Change temperature.
Uh,
So it's thermal energy per unit mass per unit change in temperature. Okay. Ideal gas
okay.
of mass 0.335 kilogram is heated at constant pressure so that its internal energy increases by 7,600 joule. During the process, the volume of the gas increases from 0.38 meter cube to 0.63 meter cube, and the temperature increases by 56 degrees Celsius. Show that the magnitude of work done is 5,000. Right? So use work done is P delta V. Right? Pressure, there's your pressure. Right? That's a change in volume. Final one minus initial one. Calculate out 5,000. Explain whether the work done on the gas is positive or negative. Positive or negative. Yep, positive or negative. Anytime they cut off already. Positive or negative.
This one is
Negative expansion. Determine the magnitude of thermal energy Q transfer to the gas. Right? Use first law. Right? Minus W. So that one is the internal energy. And 500. Okay.